Hello and welcome back to another video. In this problem, we're asked to find the exact value of each expression. Starting here with a, we have e to the 2 times ln of 3. So the first thing we can do is when we have a log with a constant outside of it, we can bring the constant in as an exponent of whatever the log is taking on. So this means we have e to the ln, which I'm going to write as log base e, of 3 to this constant, which is the second power. So again, we have e to the ln, which is log base e, of 9. And if you have e to the log base e of something, this means that we can think of it as the exponent and the logarithm canceling each other out, and you're just left with what's inside, 9. In the same way that log base e to some power, they cancel out again. Because logarithms and exponents are opposites, you're just left with what's inside. In b, log base 10 of 25 plus log base 10 of 4. When you're adding two logarithms with the same base, you can have them as one logarithm of their product, 25 times 4. This is equal to log base 10 of 100. What is this asking us? This is saying what power of 10 do we need to raise it to equal 100? 10 squared, 10 to the second power is 100. Therefore, this is equal to 2. C and D, we're going to need to do some trigonometry. So tangent of arcsin of 1/2. What is arcsin of 1/2? This is saying what angle, right, or what value, when put into sine, gives 1/2. So again, the reason I said angle is because it's easier to think about this in terms of the trigonometry rather than the just normal function which we typically deal with in calculus, right? Obviously they're representing the same thing, but thinking about it physically might help you a little bit. If we have a 30, 60, 90 triangle, the side lengths are proportionally 1, root 3, and 2, and the sine of 30, right, which is pi over 6 radians, is equal to the opposite side over the hypotenuse, 1 over 2. So if sine of pi over 6 is 1/2, arcsine of 1/2 is pi over 6. So this is tangent of pi over 6. So now this is asking us what is the tangent of this angle, which is the opposite side over the adjacent, 1 over root 3. In D, we are asked sine of the inverse cosine of 4 over 5. So again, this is the angle for which the cosine is equal to 4 over 5. Well, cosine is just the adjacent side over the hypotenuse. And so whatever this angle is, which we don't actually know, it's not like there's a 30 degree, 60 degree, 90 degree triangle for this triangle. Whatever this angle is, let's call it x. Sine of the inverse cosine of 4 or 5 is equal to sine of x. Now we just have to find what the sine of this angle is. And you can see this is a basic Pythagorean triple, right? This is a 3, 4, 5 triangle. The sine of this angle is the opposite side over the hypotenuse, which is 3 over 5. So therefore, the exact values of these expressions are as follows: 9, 2, 1 over the square root of 3, and 3 over 5.